Okay, so in this video we're going to talk about what are called complex rational expressions. So really it's when you have like fractions within fractions. So let's say you had, I'll give you a numeric example. Say you have 1/2 over 12/18, something like that. Well, one idea would be, okay, keep the first one and then multiply by and then flip that one over. Because it's just division, right? So you could work with it that way. And then, 2 goes into 18 9 times, 3 goes into 9, 3 goes into 12. So you get an answer of 3/4. Another idea, I'll use the same example, is you say, well, I can multiply by whatever I want. I'll multiply by the LCD of 2 and 18, which is 18. So I'm going to multiply by an 18 up here and an 18 up here. What's going to happen is the denominators are going to cancel the little denominators. So in the numerator now, I would get, that was a 9. A 9, 1 times 9 is 9. And then here, I'd have the 12. And then I could, now it's just a regular fraction, and I can simplify that to 3/4. Okay, so those are the two ideas. There's like two different methods. So I'm going to show you this example, and then the next video is also another example. Now, this one's a little different than my example that I just showed you, because notice that I have addition in the numerator, and I have subtraction down in the denominator. Okay, so one idea is we'll take that numerator and do the adding. Okay, so I got to get a common denominator, so I'm going to have that 1 be x over x plus 1 over x. And then in the denominator, I'd have x over x minus 1 over x. Okay, so it might be kind of hard to keep things straight here, but looking at the numerator, you have common denominators, right? X plus 1 over x. And then in the denominator, you'd have x minus 1 over x. Okay, so keep, change, flip, x plus 1 over x times, and now this one's going to flip, x over x minus 1. Okay, the x's cancel, and your final answer is x plus 1 over x minus 1. That system usually makes sense to students. I mean, it can be a lot of work, but if it makes sense and you like doing it that way, then that's great. Okay, so what you're doing is you're doing any adding or subtracting in the numerator and in the denominator. Then you're going to keep, change, flip, and finish off the problem. Okay, the other way to do it, and I'm going to have to rewrite this, is to look at all the denominators, all the little denominators, so like a 1, x, a 1, and an x. Figure out the LCD, which is x. Where can I write that? LCD is x. And then just multiply by x in the top and the bottom. Well, when you do that, you're going to distribute here. So you're going to have x plus, then you're going to have 1 over x times x. And then in the denominator, you're going to have x minus 1 over x times x. But then watch what happens. These x's cancel out, and those x's cancel out. So you get x plus 1 in the numerator and x minus 1 in the denominator. Which way do you like better? It doesn't really matter. Sometimes I think it's easier to do it this way. Sometimes I think it's easier to do that way. But you get the same answer. Okay, so that's the idea behind complex rational expressions. There's another example in the next video.